They're telling me I have a 0 at 6. I have a third degree polynomial, which should have 4 parts, which it does. And I go through the process. Drop the first term, multiply, add, multiply, add, multiply, add. Good. I know that 6 is a 0. Therefore, if 6 is a 0, the term in parentheses becomes x minus 6. Since this started as a cube, every time you synthetically divide, you drop a single degree. So now I'm left with 5x squared plus 3x plus 1. I believe that I was asking you guys to factor this fully. Find all your, I think you said find all zeros or whatnot.
Yeah.
So here I'm at a quadratic. 5 times 1 is what? 5. What times what's 5 you add together to get 3? Nothing. So you use quadratic formula.
I did, and I got this fraction.
That's fine. It's okay. So we know we have a 0 at 6. Our other one will be at negative 3 plus or minus square root of 9 minus 4 times 5 times c.
Negative 11. I got that. Check.
And that's all over 2a. So here I get negative 11. My discriminant becomes negative 11. So I have a negative 11 underneath the radical, which means that my solution zeros here, I have 2 of them that are imaginary. So all I do is just rewrite it. My answer would be 6, and then negative 3 plus or minus I root 11 over 10. That's it. That's it. You're going to start to see the questions will start to ask you guys, find all real solutions. Sometimes it'll say find all solutions. Sometimes it'll say factor. It's just depending on what it asks for. Miss Lori. Yes, because I think it said find all zeros. So we have a real 0 at 6. And the other one we had to find via the quadratic formula. 56, same deal with 56. What happens here, guys, what I was hoping you guys would have noticed with 56 is that it's given you 2 parts of that giant polynomial. It gives you 2 separate terms. It gives you a term at x plus 5 and a term at x plus 1, which means that polynomial has 2 zeros at negative 5 and negative 1. So if I use synthetic division, 2, 17, 40, 25, if I use synthetic division with my zeros, it'll factor both of them out. Watch what happens. If you drop the 2, get a negative 10, 7, negative 35, 5, negative 25, and a 0. I started with a cubic. I got to a squared term. It was a 0. That's good. So now I'm going to go to my next 0, which I know at negative 1. What I'm doing is I'm dividing them out to figure out what's left over. So drop the 2, negative 2, 5, negative 5, and a 0. This is my x term, which means my last thing in parentheses is 2x plus 5, which means my 3 parts here is this. Synthetic division is just taking terms out. If you want to think of it as a composite number, 18 is 2 times 3 times 3. So if I take out a 2 and a 3, what am I left with? 3. That's what I'm doing. Yes, ma'am.
So like what I did was like multiply the 2 parts that it gave us.
Yeah.
And then like took that answer.
Did you use long division then?
Well, no, and then I just like took them and I multiplied them like when we
Yeah.
multiplied like the money, and then like multiplied it by like, and then I had to figure out like what do I have to do to get like 2x
Yeah.
cubed,
And
and then like
you basically used a version of long division to do it that way. Is that wrong?
no.
No. Isn't this way quicker?
Yeah.
Yeah, that's fine. There's nothing wrong with it. That's perfect. That's great. I'm glad you thought of it that way.
Okay.
There's nothing wrong with that. Let's make factors. What do you got?
It was
What's that?
the same.
You could, by all means, if you wanted to put those together and use long division, it works. It's just going to take a little bit longer to get to. Because what happens once you know, if you know specific terms that make up a polynomial, synthetic division allows you to factor those terms out by dividing synthetically via their zeros. It drops degrees and it makes the numbers easier to work with. Okay? Miss Laura, you had a question on one of them?
Oh, no. You had to use quadratic formula. Got it.
All right. So you guys owe me this one. You had long division and this put together, hopefully, eventually, so and so. Yes, ma'am?
What if you brought an entirely
Then you are just going to fail miserably enough. I do, yes.
Wow.
In your locker right here?
Wow.
Or are you downstairs?
No, that's your boyfriend.
Just bring it to me later so we can, or tomorrow morning or something. Okay. So, what was it called? Basically, what this is going to allow us to do is we need to know what to do when they don't give you a 0 to start with. So far, each of our polynomials that we've had either had a term, something in parentheses, that said it's divisible by, or it gave you a 0 to start with. Well, what happens when you don't have that? Well, you have to be able to use what's called this rational zero theorem, which is a whole bunch of blah, blah, blah for the following. If I have the following polynomial, x cubed plus 2x squared minus 11x minus 12, and I want to find all the rational zeros. Basically means I'm not finding anything that's imaginary. Guys, we're not using the Chromebook, so you can close it, okay? So, if I'm not worried about finding anything that's imaginary, I don't need to worry about that later on. And I'll show you what happens there in a second. What you have to do to figure out your possible zeros is the following. Take all the coefficients, or not the coefficients, take all the factors of the constant divided by all the factors of the leading term coefficient. And then you just do a plus minus. Basically, you're working with the tails. You're working with the constant at the end and the front coefficient. In this case, my tail is a 12, and my first coefficient is a 1. So my possible zeros that I could have that could work would be all the factors of 12 divided by the factors of 1. Well, what are your factors of 12? 1, 2, 3, 4, 6, 12. Which means that there are going to be 1, 2, 3, 4, 5, 6, 12 possible zeros. But yet we know that what's the degree of the polynomial? 3. So of those 12, only 3 of them are going to work. So you have to decide where to start and check. By now you probably recognize that synthetic division, while it is somewhat tedious, is pretty darn simple. You can go through it rather quickly. What I suggest we do, just start with the easy one. 1. Start at 1, check and see if you end in a 0. If you do, great. If you don't, start with -1. This is where having a little extra paper and or an extra eraser becomes very, very helpful. Okay? It is. Yes, sir.
How many of these would be
I don't know.
like one?
No, because you'll actually be pleasantly surprised at how fast you usually find zeros. Because the way that they're written is that they don't make them out to be awful to start out with. They do set them up where they're not terrible. Well, I'm just trying to help you. That's all you do. Anybody else want an eraser?
Hey, is it purple? Hey, can I have? Do you?
Lori, heads up.
Hey.
I don't know where.
Oh!
When you were.
Right.
We tried to get
Anybody else? I got one more. Try not to snap it too hard, because these things fly if you snap them too fast. I'll show you later. All right.
You showed us with the penny.
Wait, do you snap it with the pointy part or like the open part?
Pointy part. Be careful. You have to really aim up high, because it's gonna.
I can't.
Here, right here.
I can't. I like
Daniel,
can't
your
snap
face is
it.
right where it's supposed to be.
So anyway, so you start with 1. Pull your coefficients, and you're just going to start checking. And you use synthetic division. Excuse me. And obviously at -1, it doesn't work. So I take out my trusty eraser. And I change it to -1. That's it. I mean, that's really all it is. But believe me, what happens here is you have a third-degree polynomial. What happens as soon as you get a third-degree polynomial, you find a 0, it becomes a quadratic. What can you do with quadratics? You can use, well, you can cry, but you can also use quadratic formula to be done with it. Guys, all I'm saying is that this is an unbelievably efficient way to find zeros. It's an unbelievably efficient way to multiply stuff out. It works. -1 was a 0. If -1 is a 0, what's the term? Very good. It's going to be x plus 1. Move this up a bit here. So if -1 is my 0, because it shows up here as a 0, I know that I have an x plus 1 as a term. Now, it started as a cubic. Now it's a quadratic, which means that it's going to be x squared plus x minus 12. So what times what is -12? You add together to get 1. Bless you. 4 and -3. Yep. Yeah. Yeah. And then you're done. What are your zeros?
-1, -3, and 4.
There we go. What happens here is that you might have to do it a couple of times before you find your first 0. Once you find your first 0, it flies. Yeah, absolutely. You don't. What you want to do here is, I have some upper degree polynomials, and you're going to see real quick that a lot of times once you find one, if it's a third degree, it becomes a quadratic. I can factor that. I don't have to keep doing it. If it's a 5th degree, then I go to a 4th degree, then I can go to a 3rd degree, then I can go to, there's multiple ways of getting to it.
Wait, should it be?
That's the whole point of algebra. Guys, this is the whole point of algebra here. What happens here is that since I have a 3rd degree polynomial, up to how many zeros can we have? Or actually, how many zeros will you have? 3. Whether they're real or imaginary, it's a 3rd degree polynomial, you have to have that many. Haley, you were saying something.
So, should it be negative?
The terms are -3 and 4. I'm sorry. The terms, because what times what is -12? To get to a +1, it would have to be +4 and -3,
Yeah.
which means my zeros would be at -4, +3.
But it's I thought it was a positive 4.
In the term it is, yes. You're getting terms and zeros mixed up. When I'm factoring, I'm looking for terms.
Your 0 is the opposite of what your terms are.
Yep.
But
Sorry, go ahead. No, go ahead.
okay,
Shh,
that
guys, come on.
the -1 you multiply everything by, and that x plus 1, it's a positive, so
Because-
a negative is a positive.
Because that's a 0. Are you worrying about if you FOILed all of it out? Are you multiplying zeros? Let me do another one. You'll catch. Trust me. I know you catch this. We just did this one. Let's look at this. I have a cubic function, third degree polynomial, x cubed plus 14x squared plus 41x minus 56. Which means, again, I have to worry about my factors of the constant divided by the factors of the leading term coefficient. Okay? And then it's just a matter of fishing for zeros. You're trying to find which one of them's going to give you a zero to help factor it out. Third degree polynomial, there are 4 parts to it. Do I need a placeholder? No. Be careful. You always got to watch for that. Sometimes they throw one at you. So we have our plus minus. Factors of 56 are 1, 2, 4, 14, nope, sorry, 7, 8, 14, and was it 28? 56, all over 1. What's that? Yeah. 56 divided by x. Okay. Now remember, there will be a time on this test will be calculator or non-calculator. This is something that you can do non-calculator rather easily. Okay? Especially if numbers aren't terrible. Okay? Spilled water all over myself here. So I start again. Always start with 1 because it's the easiest. Screw this up. Take your coefficients. 1, 14, 41, negative 56. And you go through the process. Isn't that nice when it happens right away? You started a cubic function, you have a 0 at 1, which means your term is what? Very good. Your term is x minus 1. And which means this part is going to be x squared plus 15x plus 56. What times what's 56? You add together to get 15. 7 and 8. See how quick that is? So you have x plus 1, x plus 7, x plus 8. Oh, sorry. Thank you.
And also it's 56, not 50.
The pen probably cut off on that one. Okay? Which gives me zeros then at 1, negative 7, negative 8. Hey, what were your tails doing on this problem? Tails, it was x cubed positive first term. Down up, very good. It's a down up. So it looks like that. Could. Can't you graph it via zeros and tails? We've been doing it, haven't we? Do you see how I keep bringing everything back together that we've been doing?
Yeah.
Now what happens when your first term is not 1?
I don't know.
Then you cry. There's only 2.
So again, we have a 4th degree polynomial. My polynomial should have 5 terms to make it work. In this case, we do. I don't have to worry about placeholders. So I look at my factors of 10. My factors of 10 are 1, 2, 5, and 10. And I have to divide that by 1 and 2. Now, that means there is a possibility of having fractional zeros. It does happen. But here's what happens. More often than not, by using synthetic division with your whole numbers, you can get through all of that before you have to worry about finding a fractional zero. It works out real clean. You have just trust me on this one. It does work rather cleanly, okay? So we start the same process. What number are we going to start with? 1. So we start with 1 and we work through our synthetic. Make sure we have all of our signs correct. and go. Drop the 2. Excuse me. Hey, look at that! I got a 0 right away. Now, because if you think about this list here, guys, this list is 1, 2, 3, 1, 2, 5, and 10. Then it's 1 over 1, 2 over 1, 5 over 1, 10 over 1, or 1 over 2, 2 over 2, 5 over 2, and 10 over 2. These I don't care about because they're all right there. These are duplicates. Because 2 divided by 2 is 1, and 10 divided by 2 is 5. So there's really only 2 other fractional ones you could possibly have. Well, 4, plus minus.
So like, so you can either use 1, 2, 5, 10, or negative 1/2 and negative 5/2.
This is all plus minus.
Oh, so you can use either one of those or so any of those.
So in this case here, I want you guys to remember, as soon as you find a 0 from a polynomial, your degree drops once. I started a 4th degree polynomial, which means now I'm at a 3rd degree polynomial. Can I factor, is it easy to factor a 3rd degree polynomial? Not really, but can't I just use synthetic division again? Because I know 1 is a 0, so I have a term here at x minus 1. So here's my suggestion. Whenever you have a polynomial and it's a higher degree usually than 3, if you find your first 0, try that 0 one more time, because it might be a duplicate. Check and see if the 1 is a duplicate 0. Remember, if something is a duplicate 0, that just means it changes direction on the axis. It's a possibility for these things, for polynomials, for that to happen. So you try it. Always try that again.
How do you know who's
It's a rule. I always say to try it, because sometimes it works, sometimes it doesn't. And obviously, in this case, it was not a duplicated 0. Okay? So then I just go and I start with my next one. I try negative 1. And I know that negative 1 is also a 0. If negative 1 is a 0, what's its term? X plus 1, very good. So now I have terms at x minus 1, x plus 1, and now I'm at a squared term. I can do one of two things. I'm at a quadratic. I can go ahead and try and see if I can just factor it. What times what's 20 to add together to get negative 9, and factor it that way. Or if you want to get rambunctious, you want to keep using synthetic, it works just the same. Personally, when I get to a quadratic, I usually just try to factor it. It's usually quicker at that point. Because we have this, x minus 1, x plus 1. So what times what's 20? You add together, you get negative 9. Negative 4, negative 5, good. Move this up a bit here. And then you just factor that via grouping. It goes back to the old quadratic forms, okay?
Wait, why are we doing that?
Get your GCFs. So you wind up with these 4 terms. There's that whole nasty looking polynomial, 4, 3, factored out. once you get to a quadratic, if you want to keep using the zeros list to see if something works, go ahead. Or if you want to go ahead and just see if you can factor it, go ahead as well. Either way, it's going to work. Okay? This tells me I have zeros at plus minus 1, 2, and 5 halves. So if I wanted to be totally crazy and rambunctious with this problem, I could have synthetically divided by the fraction, and it would have worked. I would have gotten a 0. It's not that fun to do fractions, but you could. What I'm saying here is that usually the fractions work themselves out in the end. This happened.
So the second time you synthetically divide, you use the same numbers as
Yes. Yep. Yep. Because we already knew that those were the terms of the entire polynomial, and just keep going. Always double check the one you just got a 0 with to see if it's duplicated, and just go from there. If you follow that pattern, you should be okay. All right. I remember if this is the one I wanted. No, let's go to this because we're running a little short on time. Which basically gets us to be able to do this. And like we talked here a second ago, the whole point of this entire unit of polynomials is this fundamental theorem of algebra. Basically says nth degree equals number of zeros. Pretty much, or at least this part. So if I have a 5th degree polynomial, how many total zeros am I going to have? Now that includes real and imaginary. That includes real and imaginary. Now yesterday you had a couple where you did the quadratic formula and got some imaginary zeros. Great. Today some of the problems might say find real zeros, some might say find all zeros. So just make sure you're reading carefully on what it says. Okay. Usually I ask for all. Why mess with it? Mess with it. No, I want you to be able to distinguish between the two. I'm trying to remember on the test. I think on the test I asked for real and then I asked for all later on too. So just make sure, because it's just a matter of stopping if you get imaginary, you just don't write it down. Okay. So guess what? You start doing the exact same thing. I have a 5th degree polynomial. I have to look at my tail. I have factors of 6 divided by 1. What are your factors of 6? 2, 3. I'm sorry, what?
Like when you write that you're supposed to have a lot of factors or something, are you supposed to write an explanation? Like,
That is factorial. That just means if it's 6 factorial, it's 1 times 2 times 3 times 4 times 5 times 6. Not factors. It's factorial. Okay? I have a 5th degree polynomial, which means how many parts should be in our sequence?
6.
I should have 6 terms in my sequence. Do we have 6 terms in the sequence? No. What am I missing? The third, so what do I have to put there? A 0. Very good. That's the idea. Look for a placeholder. So, gee, what number do you think we're going to start with?
1.
So we have 1, -2, a 0, 8, -13, and a 6. You have to have placeholders for this to work. If you don't have a placeholder, it's not going to work. Okay? Again, synthetic divide with the first 0 that you have in your list, 1. Yay! We found a 0 right off the bat. Yay! So I have 1 is a 0. What's its term? 1 is the 0. What's its term? X minus 1. Now, hopefully you've also realized one of the reasons why I continually write down my terms is so that when I get to the end, I know what the answers are. I have a list of them going. I don't have to go back and figure it out. I found a 0 at 1. I'm started at a 5th degree. I'm at a 4th degree. So what should I try again? Use 1 again. Always reuse what you just found, just in case it's a duplicated 0. Okay? Always, always, always. So you try again. Hey, hey, hey! Look at that! It's a duplicated 0. What does that mean? It means it's changing direction. The polynomial on the graph changes direction at 1. No, what that means is that all that means is that I'm at an x cubed, so I still have to check it again. Hey, I don't think you're ever going to find one that goes there 3 times, but you see how fast synthetic is. You can probably check it real quick. Yes, ma'am. Don't I have it posted? Give me a sec. We finish this one. Try it one more time, just for fun. And it doesn't work. Okay. Go to the negative one. Okay? And it didn't work again. Go to 2. Nope. It got all excited, like, ah, boo. Try the negative. Yay! Negative 2 works, so you have a 0 now at x plus 2. Now I'm at a quadratic. When I get to the quadratic, try to see if you can factor it by hand. So right now we're at the following. X minus 1, x minus 1, x plus 2, and x squared minus 2x plus 3. What times what is 3? You add together to get negative 2. There's nothing, so you have to use the formula. Very good. 3 and 1 won't work because if 3 and 1, if 3's negative, then you'd have, you're right, you'd have negative 2 in the middle, but you'd have negative 3 at the end. So opposite of b plus or minus square root b squared minus 4 times 1 times 3 all over 2a. Yes, ma'am? Yep. Because when you get to there, you might as well, you can just go right to quadratic formula if you want, or just see if you can factor it. That's where we get our imaginary. So here you get 4 minus 12, which is negative 8. In the discriminant now, underneath the radical is negative 8. Not yet, we can't do that because you have addition between. Give me a sec. So here you get 2 plus or minus 2i root 8, oh, sorry, root 2 all over 2. We okay with that? This is the, now the reason why I can't just do that is because of the addition. But aren't all of these even?
Yeah.
That's because, you can do it now because honestly what this is 2 over 2 plus or minus 2i root 2 over 2 because it's a common denominator. So then you can simplify that to being 1 plus or minus I root 2. When they're all 3 of them are divisible, that's the only time you can do that.
So they would ask for all the real numbers, not like real.
Yeah. Once you get to, if this asked you for all real, you would just say 1, 1, negative 2. But since it's asking for all, you gotta list that in here because how many zeros should this have had? 1, 2, 3, 4, 5. And that's how that works. Yes, sir?
I would just say 5.
Okay. Remember, the idea behind this stuff is that synthetic division is a means to factor upper degree polynomials really quickly. All right. We're going to have to go Monday. I can't do it Friday. We have still too much to finish out. As much as I thought about trying to sneak it in,
Reminder that Principals Advisory Committee will meet tomorrow during Flex in the Media Center classroom. Principals Advisory Committee will meet tomorrow during the Flex Media Center classroom.
will you text that to her? I figured that's what you're gonna do. All right. Remember, use an eraser when you're synthetically dividing, or what's that? Yeah. It's yeah. If you want, I don't care. I got one. If you want to borrow it, go ahead. I don't care. It's fine. No big deal.